Okay, let's do some more of these I call them H plus squared calculations. Okay, now these we are talking about here. These calculations work when we are dealing with a a weak acid dissolved in water. All you've added is the weak acid and water. You haven't added anything else, such as NaOH, or you haven't added any of the sodium salt with the weak acid, its conjugate base. So you haven't added any extra strong acid. So if you've done any of those things, this won't work. Okay, let's have a look at these calculations we talked about in the previous video. What it lets us do is, if we look here, okay, you've got three things: the pH of the solution, the concentration of the weak acid, ethanoic acid, whatever, and the value of the Ka of that weak acid. If you know any two of these things, you can work out the third thing. And in the previous video, what we had was we were told the concentration of the weak acid, we were told its Ka, and we worked out its pH. But you can, as long as you've got two of those, you can work out the third. Right, and the way we set out the calculation every time is this. Right, you've got the equilibrium reaction here, HA, and it dissociates. So we think about the start concentration, which we'll call HA, and we make a bit of an approximation here. Well, that the H plus ion concentration in the water is 0. It's not water. It's obviously 1 times 10 to the minus 7 mole per decimeter cubed, but that's so much smaller than the extra H plus from the acid, we can ignore it. So that's one approximation. Then we say at equilibrium, what's happened? We say that the concentration of the HA has dropped by this value X. That means the new concentration of A minus and of H plus must be X. And that's where that's why we call these H plus squared concentration, because what happens, we tend to this top value here, because H plus concentration is equal to A minus concentration. H plus is equal to A minus, so the top line of this equation becomes H plus squared. And of course, this goes back to the fact that this is only true when you haven't added any sodium hydroxide or anything, or acid or anything else, only when you've got the weak acid in there. Okay, so let's do some of those calculations then. Let's have the first one. Let's say, right, so we're going to find the pH of a 0.25 mole per decimeter cubed solution of a weak acid that has got a Ka value. The Ka is equal to 3.5 times 10 to the minus 6 moles per decimeter cubed is always the units of Ka. So we're going to do that. Right, so what we're going to do here, which one do we want to find out? We're told the concentration of the weak acid, and we're told the Ka. Okay, so we're going to find out the H plus concentration. So first of all, let's write down after this one here. Right, so Ka is equal to H plus squared, because H plus is equal to A minus, yeah? And we're going to say that's the concentration of HA. Now, strictly speaking, it's HA minus X, but remember this little approximation here. Because X is such a tiny number, we can forget about that. And so we just have HA, and that saves us having a quadratic equation, which makes the calculation easier. So, and the concentration of HA is 0.25. So let's rearrange that. H plus squared is equal to 0.25 times Ka. Right, the value of Ka, 3.5 times 10 to the minus 6. So that is equal to 8.75 times 10 to the minus 7. Take the square root of it to get H plus concentration. that's equal to 9.35 times 10 to the minus 4, minus log it to get the pH. pH is 3.03. Okay, so that was when we knew the concentration of the weak acid and we knew the Ka, and we had to find out pH. Now let's do a different one. So I'll just work this out. Right, so this time I'm going to say the pH of a weak acid is of weak acid solution. So we've got an HA solution of concentration 0.12 mole per decimeter cubed, and the pH is equal to 3.56. So we are going to find, and then we need to find out Ka. We're going to calculate Ka for this acid. Okay, so let's put the numbers in. Right, now H plus concentration, we know, let's do it here, do it in blue. H plus concentration is equal to the 10 to the power of minus pH, 10 to the power of minus 3.56, which in this case, we'll leave that as that. I'll put it in. And we know that HA is equal to the same as that. So let's put the numbers in. So Ka is equal to 10 to the power of 3.56. And we need to square that because it's HA times A minus. And then HA, the concentration is 0.125. Put that into the calculator and you get Ka is equal to 6.32 times 10 to the minus 7. And what's the units of Ka? Is always moles per decimeter cubed. So there we did that one. Finally, let's do, the final one we haven't done is when you're given the pH and you're given the Ka and you have to say what was the concentration of the weak acid. So let's do that one. I didn't mean to rub that out. Rub this bit out. Okay, so the question is, we've got ethanoic acid and the Ka of ethanoic acid is 1.74 times 10 to the minus 5, so they tell us that. And they tell us the pH of this solution is 2.65, and you've got to find out the concentration of the weak acid, which is ethanoic acid in this case. Okay, so do we know the concentration of H plus? We do, because it gives us the pH. So we know that H plus, which is also equal to A minus, of course, is equal to 10 to the power of 2.65. And we know the value of Ka, so we want to find HA, so let's rearrange this equation. So we get HA is equal to H plus squared, I'll write for the time being, all right, divided by Ka. So H plus is 10 to the power of minus 2.65 all squared over 1.74 times 10 to the minus 5. Put those numbers into the calculator and we get the concentration is 0.288 moles per decimeter cubed. So that is the concentration of the ethanoic acid, which would give you a pH of 2.65. Okay, so I'd always recommend you to write this down. Even if you think you do it in your head, probably a good idea to write it down. And then don't forget, whenever you know any of those three things, you can work out the third thing. And really importantly, this relies on A minus concentration being equal to H plus, and that is only true when you haven't added sodium hydroxide or anything else. That includes, so if you've got a buffer solution, these sort of calculations will not work. Okay.